All right, so what do we actually know about inverse functions? So just a little bit of a reminder. If we had a function, so let's just say we had y equals x squared, but we'll restrict the domain so it's just the positives. So the just write that in, y equals x squared. So remember the inverse would be a reflection in the line y equals x. So the inverse might look something like that. And of course we know that that's y equals root x. So the things to remember from inverses is the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So a couple of important things. And of course, they always reflect in the line y equals x. So we'll rub that out and we'll get started with, well, how do we do that with circular functions? So, first of all, when we're going to look at the sine x graph, and you can see that what they've given you there is just a small portion of the sine x graph. Now remember, to be a function, it must have a correspondence of 1 to 1. So I could continue that sine graph on, so it looks something like that at either end, and you can clearly see the sine graph, but it's not 1 to 1. So for it to have an inverse, we restrict the domain. Now, it wouldn't be any use restricting the domain, say between 0 and pi, because if you restricted it between 0 and pi, the function would be many to 1, and we need it to be 1 to 1. So the most sensible place for sine, and you certainly could do it in other places, is to restrict it between minus pi on 2 and pi on 2. And then, so its domain, if you want to put that in there, so its domain is between minus pi on 2 and pi on 2. And of course the range, well, that's pretty easy, just look at the graph and it goes between minus 1 to 1. Okay, I could sort of dot that across and dot that across, and you can see the range there. And of course they're square brackets. Now, rub that out. So that's good, so we know what that is. So when we do the inverse, we know that those are going to swap. Now, it's important to realise that when you do these, to draw a nice graph, you really want it scaled a little bit better than their diagram. Pi on 2 as a decimal is 1.57. So you can see their scaling is not really very nice. So if that's 1.57, that would mean that 1 would, on the x-axis, would be about here. And minus 1 would be somewhere there. That looks close enough. So if we take the endpoints, so if you take the point minus pi on 2, negative 1, if you do that round the other way, then the point becomes negative 1, negative pi on 2. So that's it, sort of starting there. So that would be minus pi on 2. And if I took the point at 0, 0, that's going to be 0, 0 still. So if I now sort of sketch in this inverse, it's going to look something like this, coming through to about there. Take the other endpoint, which was pi on 2, 1, and reverse it, so it becomes 1 pi on 2, so it will be somewhere about there. And if we flip that up there, this is what I've drawn in green, roughly. It's hard to be smooth when you're on OneNote. That graph that I've drawn in there is the inverse. And if I marked in the line y equals x, it would come through here, like that. Okay, might just label those endpoints. So this point was 1 pi on 2. And this point down here is I'm going to put some brackets around that. And this point down here is minus 1 minus pi on 2. Okay, so the graph I've drawn in there, this green graph, is sine to the minus 1 of x. Let's just make it y equals sine to the minus 1 of x. Now, another way that you can say that is, and it's used all the time, is arcsine. So get used to using that. So y equals arcsine of x. Tends to be used in the exams more than sine to the minus 1. There's no difference between them. If you've had COV before, you'll always argue arcsine, but really there's no need or no difference. Now, just consider what the domain is. So for this, the domain will be the range of whatever the original function was. So the domain is minus 1 to 1, and the range is, look at the graph there, minus pi on 2, so minus 1.57 to pi on 2, which is 1.57. And as I said, if you want to draw them nicely so they look okay, try and scale them so that your 1.57, your pi on 2, compared to what it is on the y-axis, is about 1.5 times whatever 1 is on the y-axis. All right, I'll just stop there for the first one of these little videos.